morning. Today is 25th March and it is Wednesday. This is Wednesday. We are going to continue with quadratic equation, and today is the second session of quadratic equation. In the previous video, we have seen the basic skill that is required to solve the quadratic equation questions. So today once again we will try to understand some more basic concept regarding quadratic equation, and the first thing that we will discuss is what is quadratic equation. What is quadratic equation? So quadratic equation, quadratic equation, right? Quadratic equation is an algebraic equation in degree 2. Any algebraic equation in degree 2 is called as quadratic equation, right? Equation in degree 2. Equation in degree 2. Equation in degree 2 is called as quadratic equation. This is the basic definition of quadratic equation. Alright. Now we will be studying three different forms of quadratic equation. Right. We are going to see three different forms of quadratic equation. So what are the forms of quadratic equations we are going to see? Forms of quadratic equation, right? So we are going to see the three different forms. The first form of quadratic equation, we will name it as standard form. We will name it as standard form. The first form of quadratic equation is named as standard form. Clear? In the standard form, the quadratic equation is written as fx is equal to ax square plus bx plus c, right? In the standard form, we write the quadratic equation as ax square plus bx plus c. Clear? Where a, b and c are constant. Where a, b and c are constants. Is it okay? Constant means the numbers, the numerical, the number figure, right? We will have any number, positive or negative, in place of a, b and c. Example is 5x square plus 13x plus 4 is right. This is fx. So you will have your quadratic equation in the standard form something like this. This is one example. Is it okay? Just now we will only try to understand the structure of three different forms of quadratic equation. So the first form of quadratic equation, we name it as a standard form, and the standard form of quadratic equation is in the form of ax square plus bx plus c, where a, b and c are constants. An example is 5x square plus 13x plus 4. Hope this is very clear. Then after this we have another form of quadratic equation. We will call it as product form, factored form. We will call it as factored form. We will call it as factored form. Another form of quadratic equation, we name it as factored form. Is it okay? Now, since we have denoted the standard form with fx, therefore I am going to use a different notation, gx, for the factored form, right? It is equal to a into x minus p into x minus q. x minus p into x minus q. This is factored form of quadratic equation. Similarly, same as the first one, here p and q are also constants. P and q are constants, right? So maybe if I give you example, this was the example here. The example for this one, we can write this as gx is equal to, maybe for a we can write something, say suppose half, right? It could be a whole number also. And then this is x minus 3 into x minus 2. So this is one example of factored form, right? The first form of quadratic equation is called as the standard form, and it can be written as ax square plus bx plus c, where a, b and c are constants. Example I gave you is this. Then another form of quadratic equation, we call it as factored form, because the same thing will be in the factorized form, right? In class, okay, gx is equal to a into x minus p into x minus q, where p and q are constants, and then I have given you one example of factored form. It is clear? Okay, then we have another last form, which is called as the vertex form of quadratic equation. Vertex form of quadratic equation. That vertex form of quadratic equation is, okay, the third form of quadratic equation is called as vertex form. Vertex form. Today we are only understanding the different types of quadratic equation, the different forms of quadratic equation, but the meaning of each of these different form we will be studying in detail, step by step, right? So today is just introduction of the different types of quadratic equation, and then the third type of vertex form of quadratic equation, we can write it as hx is equal to a into x minus h whole square plus k. This is the third form of quadratic equation, which we call as vertex form. Clear? Where h and k are the coordinate of the vertex. Clear? Because h and k gives you the coordinate of the vertex. That is why the name of this form of quadratic equation is vertex form. Clear? So for h and k you will have some numerical value. Even a also is called as dilatation factor. In all the different forms of quadratic equation we are using this a, and a is the dilatation factor, right? So this also could be any number. So suppose this is this time 2, and this is x minus 2 whole square plus 3. So this is one example of your vertex form of quadratic equation. Is it okay? We have used a different notation. For the standard form we use fx, for factored form we have used gx, and for the vertex form we have used hx. It does not mean that they are made for those different, right? We are just naming it for our own convenience, just to distinguish, right? But there is no rule that the vertex form has to be called as hx or factored form has to be called as gx. There is nothing like that. Okay, this is just for our own convenience, just to differentiate the three different forms of quadratic equation. We are naming them as fx, gx and hx. Is it very clear? Alright. Now, the next thing that we are trying to understand is the equivalent function. Equivalent function. What is equivalent function? Now we have three different functions. We have three different forms of quadratic equation. So we can say we have now three functions: fx, gx and hx. Standard form, factored form and vertex form. Right. Now the first thing that we will talk about these three different forms of quadratic equation is the equivalency. Equivalency of the function. Is it okay? So we will have we have three different functions, right? You can see this carefully. We have three different functions. Fx, it is 2x square plus 4x minus 6. So this is the standard form of quadratic equation. Another function we have is gx is equal to 2 into x minus 1 into x plus 1. This is the factored form of quadratic equation. And third one is hx is equal to 2 into x plus 1 whole square minus 3. This is vertex form of quadratic equation. Now you can look at it very carefully, right? They may not be looking same, right? Or they may not be same also. We don't know exactly. We just have three functions, but then we don't know whether these three functions are same or not. If the three functions, now what we can do is when we take a value of x, when we take the same value of x for all these three different functions, and if they give you the same output for the same value of x, if all the three functions or whichever function gives us the same output, those functions will be said to be equivalent. I repeat, you take a value of x, any value, say 1. The value of x we can take any, maybe positive, maybe negative, or maybe 0 also we can take, right? So I will take one value of x as equal to 1, right? This value of x will be said to be input, right? Now when you use this value of x in three different functions one by one, what is the value of fx, gx and hx is called as output. When you punch this value of x in three different functions, you will get a value of your fx, your gx and your hx. That values are called as output. So for this value of x, which functions are giving you the same output? Right? The functions which will give you the same output for this value of x, they will be called as equivalent function. Clear? If they give you different value of output for this value of x, then the function is not equivalent function. Hope you are getting my message. This is the value of x which I am now going to punch it in all this, right? I will do all this calculation verbally. Keep your ear open. Okay. Now I am going to start with the standard form. Clear? X is taken as equal to 1. So I start. Okay, anyway, a calculation I will show you here. This is the value of x, we are taking it as equal to 1. So for fx, the value of x is taken as 1. Now we put it here 2 into 1 square. For x I have taken as equal to 1, which is the input, plus 4 into 1 minus 6. So what does it give you? 1 square means 1. 1 into 2 means 2. Plus 4 1 ja 4. And then minus 6 as it is. So 2 plus 4, 6. And 6 minus 6 is equal to 0. So when you have put the value of x as equal to 1 in the standard form, it gives you equal to 0. So I will write here 0. Is it very clear? So we checked with the first function. Now let us check with the factored form. Factored form. In the factored form, we again take the same value of x, f at 1, gx at equal to 1 is equal to 2 into 1 minus 1. Because we are taking the value of x as equal to 1. So therefore 1 minus 1 into 1 plus 3. Is it okay? So this gives you what? 1 minus 1 is 0. The minute all these three terms are in the product form. All these three terms are in the product form. The minute I got this part as equal to 0, I don't have to look at the other part because the product of this whole thing will become ultimately 0. Are you getting my point on that? Because any number multiplied by 0 is always equal to 0. Alright, so there is nothing to discuss. We can straight write the value of gx as equal to 0. Is this okay or not? Okay, now we will move on to the vertex form. We will do the same thing in the vertex form. We will take the value of x as equal to 1. X as equal to 1. Now let us put it here in this formula. So 2 into 1 plus 1 whole square. and then this is minus 3. Alright, so what does it give you? 1 plus 1, 2, and 2 square means 4, and 4 into 2 is 8, and this is minus 3, this is equal to 0. Oh sorry, 8 minus 3 is equal to 5. Alright, so for x is equal to 1 in the vertex form is giving you the output as equal to 5. Is giving you output as equal to 5. Clear? 5. Now you can see here we have calculated, now we are done with the calculation of all the 3 different functions for x as equal to 1. So when we have put the value of x as equal to 1 in the standard form, we got the output as 0. When we have put the same value of x in the factored form, then we got the output as equal to 0. And when we have put the value of x input x equal to 1 in the vertex form, we got the output as is equal to 5. Now you can see which functions have the same value, right? This function and this function has the same value. That means for these 2 functions are equivalent function. These 2 functions are equivalent function, and this is not the equivalent function. Are you getting my point? So this is the test. We did with one value of x. Like this, we have to do this actually when the question is to prove the equivalency. You have to do it for at least 3 different values of x. Please remember, this is just one example. Like this, you have to take 3 different values of x and then you have to complete the task. Clear? So I am going to take another value of x. Say I will take this as equal to 0. Now when you do this equivalency question, my advice, my suggestion will be, when you assume a value for x, let us avoid the big numbers. Right? Go for all the small number, 1, 0, minus 1, or 1, 0, 2, or minus 2. So keep your limit within 1 or 2 only. Then your calculation will be easy for you. You will not make mistake. Now let us do this for x is equal to 0. For x is equal to 0. Now once again I will go back to the standard form. F, now I am taking x as equal to 0, is equal to 2 into 0 square plus 4 into 0 minus 6. Now 0 square is 0 and 0 into 2 is 0. 0 into 4 is 0. Now this is 0 plus 0 minus 6. 0 plus 0 is 0 and 0 minus 6 is equal to minus 6. Minus 6. So for x is equal to 0, you got the value of your standard form as equal to negative 6. Negative 6. Hope you will be understanding it very clearly, right? Now we'll take the same value of x in the factored form. So f, now gx. Now gx. Gx, we are taking this as x, we are taking as equal to 0. So 2 into 0 minus 1 into 0 plus 3. Is it alright? Now see what happens. 0 minus 1 is minus 1. 0 plus 3 is 3. That means ultimately we have 2 into minus 1 into 3. Clear? So 2 3 are 6 and 6 into 1 6, and this is minus. Therefore the result will be also minus. So for x is equal to 0, the value of the factored form also is negative 6. Right? So for one more time we can see that the standard form and the factored form are giving you the same output for this input. Right? So it is getting now confirmed. Now let us go to the third form, which is vertex form. In the vertex form, again we are taking the same input as x is equal to 0 and put it here. 2 into 0 plus 1 is square, and then this is minus 3 is equal to what? 0 plus 1 is 0. 1 square means 1, and 1 into 2 means 2, and then this is minus 3. This is equal to minus 1. So the value of your vertex form for x is equal to 0, the output from the hx for this input is minus 1. Once again this has come different. Can you see this? Therefore, and the value, the output of the standard form and the product form is once again coming same, and the vertex form is coming different. So now it is getting more and more clear. We are getting the more clear picture that the standard form and the product form are giving the same output for the given input. So this indicates that gx and fx are going to be equivalent. But we have to confirm it only after calculating for 3 different values of x. Now let us take one more value of x. Maybe this time we will take it as equal to minus 1. Minus 1. Okay. So when you take this as x is equal to minus 1, let us find out the 3 outputs. So first of all, in the standard form, fx is now going to be minus 1 is equal to, now 2 into minus 1 square plus 4 into minus 1. When I get negative number, I always use a bracket for precaution, right? So that I don't make any mistake. Now this is minus 1 square. This is negative base and the power is even. So the result will become positive, no? The answer of this will be just positive 1. And positive 1 into 2 is 2. Now 4 into minus 1 is minus 4. And minus 6 as it is. Now minus 6 minus 4 minus 10 and then plus 2. The answer will be minus 8. Alright. So this is the output of your standard form. This is minus 8. Let us check it for the factored form now. Factored form. Factored form is gx, and for x we are going to take it as equal to minus 1 is equal to 2 into, for x we will take minus 1, minus 1 and then 1 plus 3. Is it alright? Now when you simplify, see what you get. Minus 1, minus 2. Clear? Minus 2. Don't say plus 2. This is because not multiplication. When it is multiplication only you will apply the sign rule. Okay? This is minus 1, this is minus 1. That means these two are the same type of number. Therefore they are added and sum of the two negative number is always negative. Sum of the positive number will be positive. Obviously then sum of negative number will be also negative. So 2 into, I will write this in the brackets because it is negative. And 1 plus 3 is equal to 4. Oh, we are taking this x is equal to minus 1. So this is minus 1, right? This is minus 1. So this minus 1 and plus 3 will become equal to 2. Will be 2. Now finally, out of all these 3 terms are multiplied and there is one negative number. So the result also will be negative. Now 2 2s are 4, 4 2s are 8. So you got this minus 8. Again you can see for the third value of x also, for the third input also, you are getting the same output from the two forms of quadratic equation. One is the standard form, another the factor form. So now it is confirmed that fx is equivalent to gx, right? And now let us calculate the value of hx to give the final conclusion, final answer. So in the vertex form now we will put the value of x as equal to minus 1. So this is hx. hx is minus 2 is equal to, now 2 into minus 2 plus 1 whole square and then minus 3. What is the answer? Now minus 2 plus 1 is minus 1. Minus 1 whole square is plus 1 because you are multiplying here. You are squaring it. That means you are multiplying the minus 1 by itself. So I told you when you multiply you will use the sign rule. Okay. So this will become plus 1 and plus 1 into 2 is 2 and this is minus 3. I repeat again. This is minus 2 and this is plus 1. So this is the case of addition subtraction. The numbers are of different type, therefore we will do subtraction. So the result of this will become minus 1. This minus 1 when it is squared will become plus 1. When you are squaring you are using sign rule. When you are adding subtracting you are not using sign rule. So with that minus 1 when you multiply this 2, sorry, this minus 1 and minus 1 is square, it will become plus 1. With plus 1 you multiply 2, it remains 2. And this is minus 3 as such. Your answer of this one, your output is minus 1. Clear? So, your output for this is also again once minus 1. Now you can see once again these two functions are giving the same value, same output for the given input, but this gives you different. So from here, after this much of calculation, we are confirmed that fx is equivalent to gx. We can say therefore fx and gx are equivalent. Is it very clear? So this is how we prove the equivalency. So this is the one criteria. This is the one way through which we can prove that the given functions are equivalent. Is it okay? Another method also is there. There is one more way. Sometimes we may be asked to prove the equivalency graphically. This is algebraically. We have done it by creating the value table. This is called as value table. Clear? And after this, in the board exam, they may ask you to prove the equivalency of the given function by using graph. So for using the graph, it's not very difficult because we have almost done 80% of the work. Now 20% more work we have to do. One extra work we have to do to prove that the given functions are equivalent by graphical method. So for the graphical method, now what we have to do is we need to plot this ordered pair. Right? We will get three different graphs. One graph you will get for the standard form, another graph you will get for the factored form, and third graph you will get for the vertex form. So when I plot the graph, of the standard form, I can use the column number 1 and column number 2. Right? For your convenience, I will write this as column number 1, which is called as input. I will write this input, I. This is input. This is output 1, O1. This is output 2, O2. This is output 3, O3. Right? Now listen this part very carefully. Now we are trying to prove the equivalency of these three functions graphically. So in order to prove the equivalency of these three functions graphically, we will plot the graph of three different functions one by one. So let us go for first of all standard form. So for a standard form, when I plot the graph, I will use the first two columns, I and O1, input and output 1. Clear? So this is one ordered pair, this is another ordered pair, and this is the third ordered pair. You are all very comfortable plotting the ordered pair on the coordinate, on the grid, on the graph paper. Am I very clear? So you can plot this. Is it okay? And after all these 3 points are plotted, then you have to join them with a free hand because it is a quadratic equation. It is quadratic equation, and the graph of quadratic equation in the previous video I told you it is a parabola. It is a curve. It is a kind of curve. Am I very clear? Therefore, after these 3 points are plotted, then you have to join them with a free hand. So your one of the parabola is completed. Now when you plot the graph of the factored form, we will take the column, first column, that is I column, with O2 column. Right? With I and O2, because this is the input and this is the output of your factored form. You can take this ordered pair and plot it on the graph paper. You take this another ordered pair, plot it on the graph paper, and take third ordered pair also and plot it on the graph paper. Right? And after all the 3 points are, this is one pair, this is the another ordered pair, and this will give you the third ordered pair. You plot it on the graph paper, clear? And again you join them with a free hand. So, because these two functions already we have seen that they are equivalent, so the parabola, the graph will overlap. Means the graph will be identical. The graph will be identical. Therefore, once you have drawn the graph of this, automatically the graph of this also is completed, right? So you don't need to actually do anything for this one because already the values are same. So you just need to draw the graph for the first function. Clear? And then now you have to go for the third function. So when you plot the graph of this third function, that is the function in the vertex form, you will take the column 1 and then column 4. That is I and O3 column. I column and O3 column. Plot this ordered pair, this first ordered pair, plot this second ordered pair, plot this third ordered pair. And after all these 3 ordered pairs are also plotted, then you can join all these 3 points with your free hand. Clear? And then what you will notice is that the graph of this will be a new graph. These two will have the identical graph. These two will have the same graph, right? But the graph of this will be a new graph, which will be separate from these two. And from the graph, you will be able to differentiate very clearly that the graph of these two functions is one graph and the graph of this function is a different graph. And that's how we can conclude that the fx and gx are equivalent and hx is not equivalent. Hope the equivalent function is very clear. So we did the equivalent function with algebraic method and also with graphical method. Thank you. After understanding the concept of equivalent fraction, now we are moving on to exercise. That exercise is on page number 134. So we will do today just one question. This is introductory question, is the introduction question. Which question is which functions are quadratic? Now there are some functions given. There are total 6 functions given to us. We will discuss and find out what is quadratic function, which of them are quadratic function. But first of all, before we go to the question, I would like to ask you to tell me what is the definition of quadratic function? What is the definition of quadratic function? Because already I have explained to you. The definition of quadratic function is it is an equation in degree 2. It is an equation in degree 2. So just be mindful of that. Degree 2. When I say equation in degree 2, that degree 2 has to be always positive. Okay? Please be mindful. That degree 2, if it is in negative, then it is not quadratic. Okay? It has to be positive. Alright. Now, fx is equal to 2x square minus x. This is a very simple, this is in the simplest form. And it can be simplified, but then the highest power of the variable is how much? Is 2. And therefore, this is a quadratic equation. So I will just tick. Tick means it is a quadratic equation. It's a quadratic function or quadratic equation. Is it very clear? Now come to this part. This part. This is 3 into x minus 5 whole square. X minus 5 whole square. This x minus 5 whole square, when I simplify, now obviously I will get the degree of this x as 2. Let us see how. This is 3 as it is, and then use this a minus b whole square expansion. A minus b whole square. A minus b whole square is a square minus 2ab plus b square. So the result of this will be x square minus 2ab means minus 10x and plus b square, that is 25. Clear? And now we simplify also. It is coming 3x square and this is minus 30x and this is plus 75. This is 75. And now finally you can see here in your equation the highest power of the variable is 2 and therefore this function also is a quadratic function. Clear? What we are always looking for is the degree of the equation. If we see that the degree of the equation is positive 2, is 2, then we call it as quadratic function. Next one is this C. In the C, what is the degree of x? It is not visible. When the degree is not visible, we know that it is always 1. So when that means this is the equation, this is a function in degree 1 and therefore this cannot be a quadratic function. This is a linear function. This is a linear function. This is not quadratic, right? Because the highest power is not 2. Next one is this. Now when you operate, simplify this function, you are getting this as what? Minus 2 into x is minus 2x. Minus 2 into 1 is minus 2. And this is plus 3 as it is. This is plus 3 as it is. So finally, what is the result? Minus 2x and minus 2 plus 3 is equal to plus 1. So this is your final answer. Now in the final result, you see what is the degree of the x variable. It is 1. Therefore, this also is not a quadratic function. Is this very clear? Now you can see here, this is given to you in the factored form. This is given to you in the factored form. So you can multiply, right? When you multiply, this is coming 3 into a minus b into a plus b. So this will become x square minus 4, 2 square, that means 4. And when you multiply this, finally this gives you as 3x square minus 12. So, what is the degree? You don't have to see how many terms. It can be one term, it can be two term, it can be three term, it can be more than that. But ultimately, what is the highest power of the variable? If it is 2, then it is said to be quadratic function. So this equation also is a quadratic function. Is it very clear? Last one is x cube plus 2x square plus 3x plus 1. This cannot be simplified anymore because it is already in the simplified form. But what is to be noticed here is the degree of the function. And here in this function, the degree is equal to 3. Degree means highest power of the variable. And here this is the function in degree 3. Therefore, this is not a quadratic function. Is it okay? Thank you. That's all for today. Now, since I have already taught you equivalent function, so I will expect you to solve two questions. Question number 2 and question number 3. So this is your assignment. This is your assignment. Okay, I will expect you. You will definitely feel very comfortable doing this because these two questions are based on equivalent function. So if the question asks you to do it by making value table, you can do it by making value table. Or if the question asks you to do it graphically, then first of all you will have to make the value table, and from the value table then you will plot the graph, and that's how you will be able to prove that the functions are, which functions are equivalent and which functions are not equivalent. With this, thank you so much. Have a nice day. Take care and stay at home. Thank you.